Today, we are going to be talking about area of parallelograms. Now, you've already watched a little bit of a video explaining how the formula of area for parallelograms is derived. And so I'm just going to remind you that in that formula, we determined that the area of a parallelogram is base times height. And so when we're talking about base times height, we're talking about the perpendicular height. We're not talking about the slant height of the parallelogram because we know they have those parallel lines. We're talking about that perpendicular height, the height that's going to form a 90-degree angle with the base of the parallelogram. So we're going to go to our first example for today. And the first example is going to be an example where the parallelogram is drawn onto a grid. So sometimes the parallelogram is drawn onto a grid and it's not just given to you with like already dimensions. When we're looking at a parallelogram that's drawn onto the grid like that, we have to count how many units the base is taking up and how many units the height is taking up. Hello. Hi, Salem. I'm doing a video right now, so can I? Yeah, cool. Thanks, dude. All right. So I guarantee you he's coming back for more. We're going to start off just by counting this out. So we're going to go 1, 2, 3, 4, 5, 6, 7. That means that the base is taking up 7 units. And we are going to count the height. Now, again, we have to count the perpendicular height. So we're going to draw a little line in there. We know that it's taking up 1, 2, 3 units. Our height is 3. So when we actually go to solve that out and we write our area equals base times height, we're going to write area equals 7 times 3. And then 7 times 3 is 21. So our area is going to equal 21. Now, if we don't have a unit given like centimeters or millimeters or inches or feet, we're just going to use units squared. And area is always squared because we're multiplying base times height, we're multiplying 2 dimensions together, okay? So 21 units squared. The next example we're gonna do is actually a little bit more simple, and it's the idea that we are gonna be given a parallelogram like so. It's not on a grid, and because it's not on a grid, it's going to just give us already the height and the base that we're going to be dealing with. So sometimes they're going to try to trick you. I'll be really honest. A lot of problems will give you the slant height and the perpendicular height and the base and make you determine what you really need there. So our base here, just say, is 12. And if we are given a perpendicular height of 8, we always want to use that perpendicular height. Look for the height that's going up and down, that has the dotted line, that has the little rectangle that indicates that it's perpendicular there. And then we'll know that area equals base height. So we have to take the base, which is 12, and the height, which is 8, and multiply them together to give us 96. Now, if that was inches in our original units, then we're going to be talking about inches squared. So it's going to be A equals 96 inches squared. Okay. A final example that's a little bit trickier that we're going to work on right now is when it's asking us to find the area of a shaded region. Ooh, what does that mean, right? So in this example, we're talking about a parallelogram inside of a rectangle. Now I realize my rectangle is not perfectly drawn, but a parallelogram inside of a rectangle, and all I want to know is the area of all of this shaded region, which is just the blue, okay? And so the way that I write that out very often is by talking about, okay, well, I need the area of my whole rectangle minus the area of my parallelogram on the inside, because I have to take away the area of the parallelogram on the inside in order to solve that out. And so we're going to do that really slowly here together. I'm going to rewrite it on the back. We've got area of rectangle minus the area of the parallelogram. And so the rectangle is base times height. and we've got to talk about what the base and the height of that rectangle are. And so if I show you here, you'll see that the base is 31. And so we're going to have 31 times 18 to find the area of the whole rectangle. Then we've got to subtract out the area of this parallelogram, and that has a base of 13 and a height of 6. So then we're going to have to subtract out the base of 13 times 6. Okay? So we have to solve that out. We've got to say, okay, well, 31 times 18 is 558. Could have done that wrong. Let's double check that. Yeah, 558. Do your long multiplication there. And 13 times 6 is 78. And so if I subtract the 558 minus the 78, we get 480. So the area of the shaded region there is 480 units, or whatever the unit was, units squared. And so I know that takes it up an extra notch, but anytime that you've got a shaded region, a shape within a shape, and a shaded region, you're probably going to have to subtract those out to figure out what the shaded region area is. And so you just take the area of one minus the area of the other, and then you get the total shaded region. So area of parallelograms, base times height, not slanted height, perpendicular height. I always write this example, like no one wants to know at the doctor, like, oh, I want to know your height. They don't ask you to stand crooked against a wall. They want to know what your height is when you're standing perpendicular to the ground. And so that's the idea here as well. Tune in to any of our Zoom conversations and ask any questions you've got, but I'll see you later.